All right, so now that we've defined vectors, what we usually like to do in math is define operations on them. So what we're going to be looking at is adding, subtracting, and then multiplication. All right, and on this particular video, it'll be adding and subtracting. All right, so basically, when I want to add two vectors, let's say the vector u plus the vector v, it's pretty easy because all you need to do is add their like components. All right, so if vector u is a comma b, and we're adding it to a vector v, let's say that is c, d, then their addition is basically adding up the two x components, adding up the two y components, and basically going from there. So that's pretty easy stuff, all right? If we were to subtract them, right, then this operation would pretty much look like this. What I have here is a scalar multiple. So my vector A, right, we're essentially going to be negating both the x and y components of my vector V. And so doing the addition, we see that this is just basically subtracting my x components and subtracting my y components, and then that would be the vector u minus v. So in essence, it's that easy. Visually, what's going on actually makes this a little more interesting, and you can start to see the applications. There's basically two ways to visualize what's happening here. The first method, I like to call tip to tip, and the other method is famously known as the parallelogram. And this kind of helps us see, in either case, what we have is called the resultant. All right, so how do we see this new vector u plus v or u minus v? Well, if we go the tip to tip route, right, visually what's happening here is we'll start off with the vector u, right? So let's just imagine the vector u looks like this, all right? And then there's its start point and its end point. To add v, all I do is start v at that point and then tip it off to there, right? And then there's the vector v. And so remember, vectors are equivalent. So even if I would have put v there, right, it's the same thing as moving it up here. And as a matter of fact, you can start seeing the parallelogram that I'll share with you real shortly. But the resultant is this guy right there. There's the u plus v new vector, right? So that would be the a plus b. So I like to call that tip to tip. So we start on one vector and then just basically add the new vector on top of the, you start at the tip where the first one ended, you put the point of origin of the other vector. And as you can see, right, when we draw a parallelogram, what I'm basically doing is putting both vectors, dare I say, in kind of standard form, right? So here's the vector u, and here's the vector v. And both of these, if we kind of go through, form a parallelogram, right? So here's the vector u, and here's the vector v. And the resultant is basically, right, what we get when we start from the initial point along the origin and all the way across to the most, the other vertex, right, where these two guys meet. So that's basically that. My pictures are a little off, but you can see that the u plus v is pretty much in the same spot. So that's pretty much how we visualize vector addition and vector subtraction, if you would, all right? Subtraction is actually a little bit tougher, right, because we are going with negative v. So if I was doing this tip to tip, or how about I do this parallelogram-wise, I'd start off, right, here is my vector u, here is my vector v, but I'm going, it's opposite. So opposite would be negative v. And so if I now draw my parallelogram, right, there would be the vector u minus v if I was subtracting. Over here, right, again, we start with the vector u, and if I go tip to tip, the vector v would take us back. So there's negative v, and there's u minus v. So that's basically how we can visualize what's going on. In practice, it's just as simple as adding and subtracting the vector components. That's basically it. So with that in mind then, right, doing some examples here, right, what I like to do is, first of all, let's just find negative v, right? And that basically means that we're just taking whatever v is. In this case, it's defined to be 4, 3, right? And then all I got to do is that scalar multiplication is multiply that in there. So I got basically the negative 4, negative 3 vector. So both the x and y components were essentially negated. The vector u, again, I have it in a new notation. I've got it in the ij notation, but in essence, what we're doing is we're multiplying it by a negative. So distributing it, right, we get 2 in the I direction and negative j in the j direction. So there would be negative v, and here would be negative u. All right, u plus v, well, again, following my definition above, I'm going to take the vector u, which is 4, 3, and add it to the vector u, which is negative 2, 1. I'll put both in that same component. So adding my x components, this is 4 plus negative 2. Adding up my j components, this is 3 plus 1. And so we end up with the new vector 2, comma 4. Right? And so therefore, so for these two given vectors, right, that's what basically the addition would look like. If I want to subtract them, right, I'm basically taking the vector 4, 3 and subtracting the vector negative 2, 1, right? And so in essence, that's 4 take away negative 2 and 3 take away 1. And so we end up with 6, comma 2 as our answer if we subtracted v from u. Right? And then we can even bring scalar multiplication. Again, scalar multiplication, all we're doing is doubling up the vector. So in practice, I've got 2 times the vector v plus 3 times the vector u. I'm going to go ahead and use this notation there. So what I have here is 8, comma 6 added to negative 6, comma 3. And if we add up the, well, let me go ahead and just show it. So I'm going to add up the x components, add up the y components, and we have our vector. So our new vector here would be 2, comma 9. Alrighty, and then last but not least, again, using my notation, I'm going to take 3 times the vector v, which is 4, 3, and I'm going to subtract 2 times the vector u, which is negative 2, 1. So we get negative 3, negative 9, and we're going to basically be, how about if I distribute that? We're going to be adding to that 4, comma negative 2. So adding up my x components, adding up my y components, right? We have the new vector 1, comma negative 11. All right, and so there's basically how you add and subtract. All right, so let me go ahead and stop there. I'm 8 minutes into this. We'll do number 4 on another video where we actually draw pictures, right? We're either going to go the tip-to-tip route or the parallelogram route to visualize what these additions and subtractions look like, right? But I'll do that in another video coming soon. Talk to you later.